So, very shortly, an introduction about ClusterCockpit. What is it? It's a job-specific performance monitoring framework for HPC clusters. It consists of multiple components. There are node agents. There are node agents running. There is a backend. It has some REST API. There are different databases required. And all this is then presented to the user with a web user interface. Today I only will talk about CC backend. Still better like that? Okay. Okay, so today it's only about CC backend, yeah? The web backend, yeah? The initial commit was in 2018. There was a preliminary, I can't speak this word, so some previous development at a prototype, but we started this to have something that also could be offered to the outside world. Yeah, usually those kind of things at many sites are developed just for within the computing center, but we wanted to create something that maybe is also usable and maintainable by outsiders. It's an open source project. You can get it on GitHub. And yeah, so now how did we start? So in the beginning, I did software development before I implemented Liquid performance tools, other things. I implemented websites before, but I never did something in web development at this scale. And web development involves a lot of different technologies. And I was in the beginning really overwhelmed. I didn't know where to start because there are so many technologies you could choose from, yeah? And I come to that later when I talk about technologies, maybe the wrong term. So I was kind of scared and I was not really sure how to start. So I was searching for guidance and best practices and something I could adhere to, yeah? Where I could stick to something where I knew, okay, things are done like that. And well, as you might know, this was some years ago, and in web development, things move very quickly, yeah? Because it's very important. A lot of people develop it, and a lot of industries are relying on it, so things move very fast. At that time, I figured out, well, model view controller is something that seems to fit, and maybe you need also an ORM. I didn't know before what this was, yeah? And so I said, okay, let's search something that provides me this stuff. And there were different options, and I looked at some of them, and I ended up with Symfony. Why Symfony? Symfony is a PHP web framework, still around. Well, and this was a matter of taste, because I don't like Python. I put it straight out. I hate Python. And I was a Perl programmer. Perl is my scripting language of choice. I don't know. It's not very modern today. And Symfony is in PHP, which is very similar to Perl. So that was the decision. And of course, Symfony seemed to be professional. Yeah? Good documentation, was a company behind it. It seemed to be something that is stable. So I started with it. And Symfony is not bad, not to say. So I started with it and started to develop my stuff. Yeah? So now, one thing I forgot, and a lot of people forget that in web development, there are core technologies. Nobody talks about the core technologies. It's all about frameworks, yeah? About stuff you need. So the core technologies is simple. You have HTML. This is for the semantic, you could say. You have CSS, styling and layout. And you have JavaScript for the dynamic stuff. Yeah? It's an interpreted language that's run in the browser, yeah, at the user side. And the common law, I never thought about doing this stuff directly in those core technologies because it was clear you cannot do that. It's not feasible. You need something. You need some framework, something that helps you to tame this complexity. So a lot of people think web development is chaotic and messy, and so you need a framework. And I think this is promoted by the fact, first of all, that the technologies are really evolving very quickly. Things are changing quickly. When you are not in the scene for 1-2 years, everything seems to be different. Yeah? Then there is endless information and resources. There is a whole army of influencers and bloggers whose only job is to promote and advertise the next big framework. Yeah? And you cannot live without this framework, of course. Yeah? And of course, when you are a newcomer, it's very difficult to decide what makes sense and what doesn't, because there is so much information out there. And also a problem, most programmers are autodidact, lateral entrant, non-professionals. Yeah? Well, a website, everybody can program a website, yeah? The browser will make something out of it, yeah? It's maybe not so different in the research community because most people are also not computer scientists. Okay, so how did we start out? The first stack, version 1, Symfony, we used a and Symfony itself builds on other frameworks. Yeah? So Symfony, the stack used Doctrine, it's a PHP thing for the object relationship manager, Twig for the templates, and the FOSS REST bundle for taming the REST API. Then you need some utility applications, you need a JavaScript package manager, you need a PHP package manager, a lot of external components, MySQL database, Symfony kind of needs a database. Then Redis for caching, because in the beginning I had severe performance problems. The thing just didn't work. Everything was too slow because we consume a lot of data, we present time series data, plots, tons of plots, and this just didn't work out. And you need a web server for a PHP. You need usually a Apache web server, which is a complex thing by itself. Then, of course, for the front end, at that time, I implemented everything with jQuery. I used Bootstrap for having the CSS thing controlled, data tables and Plotly. So data tables is a jQuery, essentially dynamic table library. And Plotly is a plot front end, yeah, in JavaScript. And what was the experience? I wasted a lot of time with all those frameworks. The fraction of time I spent managing the frameworks, getting this whole thing work at all was a lot. And not a lot of time I could spend in actually implementing the stuff which was my application. Yeah? Then it really didn't work that well. I had performance problems. And for production, I mean, I wanted this to be used by outsiders. You know, when you have one website and you use Symfony, that's fine, yeah? You learn how to use it, you learn all the quirks, you set up the website, it's running, yeah? But if you want that this is downloaded by something and set up in a production environment, that's a completely different story. And people were completely lost in setting this up. Most people in HPC environments, they didn't even manage to set up a MySQL database server. They already failed with that, not to speak all the other stuff. Then a big problem is this composer thing. The whole package manager, it's fragile. It breaks all the time. And when it breaks, it's difficult to fix. Yeah? And the problem with that is the update is at the customer. The customer has to download all these fucking PHP files and do the update, and it breaks all the time. It's difficult to fix. So version 2. In version 2, we switched to Svelte to fix the performance problems. Yeah? And we used another plot library, uplot. It's a JavaScript library. The other stuff kind of stayed the same. We used InfluxDB for a time series database. Before I stored all the time series data in the MySQL database, which kind of worked but was slow. And things didn't change really. I still wasted a lot of time with the framework. The production setup was even more complicated. And as a solution, what I did is I provided a Docker Compose setup so that people just can run Docker. The problem with Docker is, well, for production, people use Docker is also difficult. You have to set it up, you have to secure it. And it's also complex. If something goes wrong, you also have to maintain it. And for us, we spend a lot of time getting all this in a working, maintainable way in a Docker Compose setup. Yeah? So was not really the solution. So now, one problem there is, and I say that because, for example, my administrators, when I came up with Golang solution, it was very skeptic. And it kind of seems to be a tradition that if it should be professional, it has to hurt somehow. It has to be complicated and broken in a way. So this is the PHP Symfony framework. You have all those components with which you have to set up. In production, you have 160 megabyte files, thousands of files. You have Composer, Webpack, which you have to run as a user to set this up. Yeah? And you need an optimized configuration with a web browser, with PHP, fast process manager. It's complex. And a non-expert without Docker, sorry, you are lost. You will not manage to set this up. So now, with our Go-based setup, what do we have now? And I come to the other things related to Go. It's one binary. It's 29 megabyte, just one binary. To install, you just throw in the binary there and start it. That's it. Everything is included. With regard to configuration management, everything is embedded in the binary. All the static assets, all the JSON files, everything is embedded in this binary. It has a simple systemd setup, yeah, which we provide. Simply installed, you can run it without any hassle. And upgrading, as I said, is just a matter of throwing in this binary. You can download this binary, it will run on any Linux system, and it just works. No special domain knowledge is required. So, what is the main advantage with Go? So I was skeptical, and one thing I want to tell is, how did we get to that? I had Go, I selected Go for the node manager and for other tools, but I kind of was skeptic to go for the web application. And the reason is, Go has a bit of different strategy. There, the spirit is not to use frameworks or high-level libraries, but the core library, standard library, provides everything you need to develop a web application. It has an integrated web server. It has all other stuff, authentication, everything is there. Yeah? And you should implement that on your own. And in the beginning, I was skeptical that this is feasible. I had a Hiwi student at the moment, and he was so frustrated by this PHP stuff because he wasted so much time struggling with this thing that he just did it. He just implemented this thing in Golang. And the fascinating thing was, he implemented, for example, the authentication based on the standard library, and it was not more code than implementing it for the framework. The good thing is, he has no transferable knowledge because he learned about the actual authentication protocols and not about the framework. And it didn't require a lot more code. And it's a lot more flexible. We can do it exactly like we need it. And it also makes things a lot simpler. So for me, the main advantage of Go is focus on simplicity. And it's not the programming language. I think you can do large-scale projects with any programming languages. That's more a religious thing. What in my opinion, is important for the productivity and especially for long-term maintainability is the ecosystem, the tooling. And in Golang, the tooling, it never gets into your way. It just works. Other modern languages have the same thing. Yeah? Nowadays, modern languages always have to have a built environment included, everything included, despite of the poor C++ guys. Yeah? But otherwise, they all have it. But I think in Golang, it's done especially well. It works especially well. It never gets into your way, and you just realize how well it works when you go back to another languages. Yeah? You never have a problem. There is minimum distraction. You really can focus on what you want to do, implementing your stuff. Yeah? And very important, and I know C++, all standardized languages, they can't do that because you have some minimal common denominator, and so they cannot provide a complete standard library. And that's for me the main issue with C, that the standard library is just bare bones. Yeah? In Go, for that application, for web applications, is a complete standard library. It comes with everything you need to implement a web application, including the web server, including SSL, including everything. Yeah? And it's easy to use. And even more important, while performance is not at the focus of Golang, yes, it's threaded, but it's more about productivity and about this flexibility. Yeah? It's more about this triangle between flexibility, functionality, and productivity. The performance is much, much better than before. We have no performance problems anymore. Yeah? And threading is quite simple to use, especially when you have something like a web server where for every request you start at one of those lightweight threads. Yeah? So it really works very well. So, take-home message. I started with PHP. I don't say this Symfony is bad. It may be good for some other application where you follow in the documentation, they have some blueprints. And if you stick to this standard use case, it's fine. You throw everything in, everything is included, you configure it, it works. Yeah? But as soon as you have something a bit more complicated, that's a bit beyond what is described on the website, I promise you, you will run into problems. And to fix those problems might be complicated. Yeah? That's another thing. One thing I want to mention is Golang, you may know it, is not object-oriented. The PHP Symfony, it was object-oriented. And they had a bug in the authentication. They changed the authentication subsystem 2 times while I was using it and deprecated the old one. And it didn't work. And I tried to reverse engineer. You might know documentation is really, in a lot of cases, not helping. You need to look at the code often, yeah, because that's where the truth is. And to reverse engineering this stuff was really pain. Why? Because it was completely over-engineered, object-oriented shitload. Yeah? And in Golang, this just doesn't happen. Yeah? It's simple. And it also manages to do complex software. You don't need this over-engineered, I anticipate every future development for that. Yeah? Okay, so I can recommend it. I think it's well suited for web application backends. I think that the people who develop it, they know what they're talking about. They come from an industrial environment where it's important that the productivity is at a high level, that it doesn't cost, that you manage this complexity in developing software. Yeah? And Golang provides this. Yeah? It's a simpler solution and therefore, in my opinion, a better solution. And what I really like most is, in computer science, often when you have complexity, the basic strategy is to bury it under another layer of complexity, yeah, and hope that it works then. Yeah? But that's a lie. And here it is tried to reduce the complexity where it's created at the root, and that's much better. Yeah? So, yeah, that's it.